Hello, welcome back to my channel. Today we're going to go over types of nuclear decay or solving nuclear reactions. So there are three types of radiations. So I've already listed them here: alpha, beta, and gamma. And obviously they have different symbols, and I have also written down the symbols, the isotopes that you'll use to solve nuclear reactions. So alpha is the weakest out of the three, and it's basically the helium isotope. So the mass of 4, charge of 2, so literally just the isotope of helium. Beta is stronger than alpha, but medium penetrating power, so it's the same as the electron. And then gamma is the strongest, and it has 0 mass, 0 charge. The reason for that is because gamma radiation is waves, they're not particles. So alpha and beta are particles, gamma is waves, and gamma is the strongest. So to remember the strength, alpha will be the weakest, gamma is the strongest. Alright, so whenever you solve for nuclear reactions, it's all about isotopes and just basic mental math, like addition, subtraction. So if I just give you, for example, 239.90 thorium, and it's going through an alpha decay, you're going to figure out the missing isotope. So with this yield arrow, I always treat the yield arrow as an equal sign. So that means the isotopes on the left side have to equal the isotopes on the right side, hence the balanced reaction. So the top numbers have to equal, the bottom numbers have to equal. So I like to start with the numbers first and then figure out the missing element. So 239 equals 4 plus what? So if you need to do a little algebra to the side, you can do that. So 239 equals 4 plus 235. Or if it helps you to subtract, like 239 minus 4 equals 235. So whatever works for you to solve. And then the bottom number, same thing, 90 equals 2 plus what? So 90 minus 2 is 88. So now that we have our top and bottom number, again, you got to remember with isotopes is that the top number always represents the mass, the bottom number always represents the atomic number. So we are looking at the bottom number to figure out what element that is. So 88 on the periodic table will be radium, and we're going to write that symbol Ra. And that's it. That's pretty much how you solve like a missing isotope. So that's alpha. Now if I give you beta, for example, let me give you 2:45:95 a.m. This is the beta example. So again, same rule applies. If it helps, definitely write an equal sign. It helps me definitely. And so we solve for the top and bottom number. So 245 equals 0 plus 245. That's why I love beta, because the mass number changes. But then the charge, that changes. So 95 equals -1 plus what? So with the -1, you got to be extra careful. So -1 plus 96 is your answer here. So it is very common for people to do, 95 minus 1 equals 94. That's my number. But no, again, you got to treat this as equal sign. So like I did in this first one, you can subtract, like 90 minus 2 equals 88. If you do 95 minus -1, so minus negative, that turns into a positive. So 95 plus 1 is 96. And then we look at 96 on our periodic table. If I can find it, it's in the bottom here. Curium, Cm. Okay. So that's alpha, that's beta. How about gamma? So gamma is actually the easiest because it has 0 mass, 0 charge, so since it's a wave. So does that mean it changes anything? If it's 0, 0, right? It doesn't change because 0, 0 is still 9, 4. That's literally it. So there's not really much you can do with gamma, because again, gamma being waves, it literally just goes through the isotope. It doesn't change the element, right? So I'm going to give you an example of one of each, and you're going to solve on your own. You should have a periodic table to solve it, and then you should pause the video and then solve them, and then play the video to check your work. So let me give you this example here. Alright, so I gave you an alpha, beta, and gamma. Go ahead and solve these and pause the video to work it out, and then play once you're ready to check. Alright, these should be your final answers. The gamma should be a given. It should be the same, so maybe you did this one first. Alpha, it changes to, or it produces argon. And with the beta, again, 15 minus -1. So that would be 16, and then 31, the mass doesn't change. And number 16 is sulfur. All right, so that is how to fill in the blank, essentially. But what happens if I ask you to write a full reaction? So, for example, I ask you to write alpha decay of uranium 235, right? So notice how I've given you an isotope that's in the hyphen notation, and we have to have the nuclear reaction in nuclear notation, and you have to know what alpha decay is. So remember, alpha is, so I'm going to write this to the side where we have reference, so 42He, that's our alpha, our electron is our beta, and then our 00 gamma is gamma, obviously. Okay, so whenever you have like a word problem like this, your first thing to do is to convert your hyphen notation to nuclear notation. So uranium, we all know that uranium, the symbol for that is U. 235, that is our mass number. And remember, the mass number goes on top. If you put it on the bottom, that's going to mess up your whole reaction, and you get a different element and whatnot. And then uranium, according to the periodic table, is number 92. So that goes on bottom. Right? So alpha decay now. So when you think of the term decay, decay means to break down. And so when it breaks down, you don't add anything. It just literally immediately arrows. So if you notice what I did earlier, it's always the isotope, arrow, isotope, arrow, isotope, arrow, because it breaks down. That's the point of decay. Right? And then since it says alpha, I'm going to put my alpha symbol, alpha isotope, the helium. And then from there, we just solve the rest of it, like we just did. Okay? So, the top number, 235, equals 4 plus 231. Bottom, 92, equals 2 plus 90. And then number 90 on the periodic table is thorium, Th. Right? Give you an example with beta. So beta decay of Cu 65. So Cu 65, we're going to convert that to nuclear notation. So Cu is my symbol. Remember, 65 is my mass number, so that goes on top. And according to the periodic table, Cu, copper, is number 29. So 29 goes on bottom. And now we break it down. So decay, and then my beta is my electron, plus, and then we find our missing isotope. The top number would be 65, because the mass doesn't change here. And then the bottom number, so 29 minus -1 is 30. And number 30 on the periodic table is zinc. Right here, just right next to it. Okay? Alright, so I'm going to give you 2 more examples to try by yourself. And again, pause the video and then check your work once you're done. So I will give you first alpha decay of aluminum 27, and then beta decay of chlorine 37. Okay, again, pause the video, work it out, and then check your work once you're done. Alright, here are your final answers. So again, alpha is the helium, and what I got was 23/11 sodium, Na. And then for beta, I've got the 37/18 argon. Alright, so that is pretty much it for nuclear reactions. I hope this helped, and stay tuned for the next video. Have a great day.